Okay, 5.2 is about the exponential function, and this is it here. Very simple. It's a base raised to an exponent, which we've seen before, but we're going to be looking at the function and some requirements. B has to be positive, and the reason for that is certain exponents may lead to imaginary or complex numbers. So to keep it real, the restrictions are b is greater than 0. And then also, if you remember, if I take 1 to any power, it always equals 1. So if b were to equal 1, this would just be a constant all the time. Wouldn't really be a function that you could graph very well. So the other restriction is b cannot equal 1. So what I'm going to do right now is just go through the rules of working with exponents, and you can find them at the beginning of chapter 5.2. So look for that. I believe it's on the first or second page. All the rules are there that I'm going to talk about here, but what I want to do is lay them out and just show you how they work, because on the surface, some of them look a little interesting, although you may be familiar with a lot of them. But when you think about the rule in terms of a real number example, they really make sense. So let me go through the rules, and then I'll work one example problem of kind of using all the rules together. You can see how they work to simplify exponent problems. Okay, so the first rule, if I have a base, and we'll just pick 5, and I raise it to a power, and then I multiply it by that same base again, raised to the same or a different power, what is the rule for that? So our first rule is b to the m times b to the n. What does that equal? Well, the rule is easy to figure out. Even if you forget it, you can pick a simple example and just work it. So 5 squared, if you remember, that just means 5 times itself twice. Okay. That's 5 squared, and we're going to multiply that by 5 to the 4th, so that's 5 times itself 4 times. Well, if I count up the number of multiplications there, 1, 2, 3, 4, 5, 6, that's the same as 5 to the 6th. So what did we do? We just added the exponents. So there's our first rule. Okay, rule number 2 would be something similar with division. So let's look at this. So if I have b to the m and I divide by b to the n, what is the result? Again, we can figure it out real easy with regular numbers. This is 5 times itself 4 times. And down here we have 5 times 5. And what we can do here, since it's a fraction, it's all factors, we can cancel. But what does cancel mean? It means I'm taking away a 5 from the list. I'm taking away another 5 from the list. So I'm taking these 4 and subtracting 2. So this reduces to m minus n. And again, it's easy to see. So the key here is the base has to be the same. So for example, if this was 5 squared times 3 to the 4th, there's no rules for that. You just have to try and figure out what each of these equaled by going through all the multiplications. So the base is always the same. Okay, next. Suppose I have a base raised to a power and I want to raise that whole thing to another power. So now we're looking at this. So what does that equal? Well, again, we can do it here. This is the base. That's 5 times 5. That base is going to be multiplied by itself 4 times. Two, 4, 6, there's 8 of them. And how did I get that? I multiplied 2 times 4. So I'm multiplying the bases. So there's our next rule. Okay, these are the main rules. Now let's move on to something that we can use here. And let me go ahead and finish this. This was just 5 squared, 4 minus 2. Suppose I did this different. Suppose I had, the problem was like this. Well, if I use the rule as is, I'm subtracting the bottom from the top. But I'm going to wind up with a negative exponent here. And when you're working with exponential problems, and especially when you're trying to simplify, you always have to have positive roots when you're done. That's the simplified form. Plus, when we're working with numbers, 5 squared is 25. 5 to the minus 2, that doesn't really make a lot of sense in that form. So we need a rule to convert that. So the next rule is, if I have a base raised to a negative, I just take the reciprocal. It's a funny looking rule, and let me apply it here real quick. That means this would be 1 over 5 squared, which would be 1 over 25. So let me write the rule here really quick. But the rule is really much more than this. What the rule really is saying is, whenever I have a negative for a root, I can move to the other side of the fraction bar and it becomes positive. So for example, what if I had this? If I want to make that negative a positive, move it to the other side of the fraction bar. Okay, if I wanted to make this negative a positive, I moved it to the other side of the fraction bar. That's all you got to do. It shows up again in another rule here. Now, for this rule, I have different bases. And in fact, I could have a whole bunch of things in here. This could be 2x, y, z cubed. This could be 5x over y squared. It doesn't matter. What matters is this. It's kind of like if I was multiplying out here, I would multiply everything by what's out here. When you have parentheses and you have this is the base. That means that exponent applies to the entire base. So for example, here it would be a to the n over b to the n. Here it would be a to the n times b to the n. You can mix them. Suppose I had a squared b cubed to the fourth. Well, it's just this exponent applied to all of these. The problem with the example in the book is they keep it very simple and they only have exponents of 1 here. But in this example, you'll see if I apply this exponent to this exponent, that's raising a power by a power. Okay, now we're back to this rule. You multiply them. So that would be a to the 2 times 4, b to the 3 times 4. Okay? Another rule. So keep these in mind, even though they're very limited. You want to think more along these lines. The final rule, and then I'll go to a big example, is this one. Let me start here. Again, when you have that negative sign, if you want to turn a negative to a positive, what do? You move everything to the other side of the fraction bar. In this case, you'd be taking the reciprocal. So this final rule says you can do this. Change it from a minus to a positive, take the reciprocal, and then you could use this rule. The answer here then would be a to the n over b to the n. Now, as long as you follow the rules, it doesn't matter what order or how you use them, as long as you use them the way they're intended to be used. So let's look at this example right here a little bit different. Suppose I did this. I could start with this rule, where I multiply the exponents. What would that look like? b to the 1 times minus n over a to the 1 times minus n. And then what would I do here to make them positive? Move this one up, change the sign of the exponent. Move this one down, change the sign of the exponent. It's exactly the same answer as if I did it this way. Okay? So, we have a lot of rules here, and you can use them pretty much in any order or any way you want. As long as you do them correctly, you get the same answer. So let me finish up with one large simplification problem here. So let's simplify this. And there was something similar to this on a math qualifying exam at the school where I used to work, where everybody would have to take the test to find out where they placed as far as what classes they would get to start taking. And at that particular school, it was a 4-year university, it was assumed you could do this. But I think it's a pretty interesting problem. Pretty much uses all the rules we just talked about up there. Okay, so there it is. What you don't want to get stuck on is this: how do I start? Because there's about 10 ways to start this thing. Look, I could start by making all the exponents positive. I could move this down, make it a positive 1, then add these because I'm multiplying. That would be a c squared. I could do the same thing here, move the a minus 2 down, make it an a squared times a to the first, it'd be a cubed. That's one possibility. Ultimately, I'm going to have to apply these roots here, or these exponents, so that I can get rid of the parentheses. But you don't have to get rid of the parentheses right away if you don't want to, or you can. It's up to you, as long as you follow the rules. Here, like I showed here, I could go ahead and raise all these to the negative power, Or I could take the inverse, or the reciprocal, and change that to a positive 1, which would then be to the first power. You're done. A lot of ways to do it. So let me work each one different ways. Let me work this one by just go ahead and applying the exponent right away. So that would be 3 to the 2 times 2, 3 to the 4th, A 1 times 2, B 3 times 2, and C minus 1 times 2, that's C to the minus 2. Down here, 2 squared. I'll do the numbers in a minute. B squared, C squared. Times. Okay, for this one, I've decided I'm going to go ahead and work inside the parentheses first. I'm just showing you can do these things any way you want. I'm going to go ahead and do this. I'm going to bring this down, and it'll become A to the plus 2. So that would be A squared times A. That'll be A cubed. Okay. Now, I'm going to use, where is it here? I'm going to use this trick. I'm going to go ahead and just take the inverse of keep saying inverse, take the reciprocal of this. So let me simplify this a little bit. 3 to the 4th, that's 81. Okay. 2 squared is 4. Now I'm moving along here. I don't have any A's down here, so I'm just leave A squared. Here I have a B6 and a B2. And that's division. That's this rule here. And in the interest of positive exponents, you always want to move the smaller exponent. In other words, subtract the smaller from the larger. So when I look at this, I got a 6 and a 2. I'm going to get rid of the B2 and subtract it from the 6. So B to the 6 minus 2 is 4. Same thing here. Minus 2 is smaller than plus 2. So I want to get rid of this one. Now here's where you got to be careful. I've got C to the 2, and what does the rule say? Subtract the other exponent. So that means I'm going to subtract minus 2. Okay, so you don't want to miss that. That's going to become a plus 2, and that's going to wind up being C4 down there. All right, here, if I take the reciprocal, that becomes a plus 1. So I'm going to have this. And then since that's a plus 1, anything to the 1 power is itself, so I don't need the parentheses or the exponent anymore. All right, so let me change this now to a plus 4. So we have, okay, that becomes C to the plus 4. Okay, now I'm multiplying things together. I'm up here. When you multiply things, you add the exponents. So what do we got here? 81, that's fine. A squared times, oh, hold on a minute. Not quite right. I could multiply 81 times 2, but since we're in a fraction here, let me go ahead and cancel the 2 out. Okay, now I can just put 81. All right. A squared times A cubed, add the exponents, that's A5. B to the 4th. Yes, I could divide right now, but I'm just doing things however I want. Again, as long as I follow the rules, we're okay. Down here I got a 2. I got a C4 times C3. I'm going to add those exponents. That's C7, and I also have a B here. You don't have to write them in alphabetical order, but that's kind of a generally accepted way to do things. All right, so my final step, can I do any division stuff? With numbers, no, that's odd, that's an even, there's nothing there. So 81 over 2. Can we do any of this stuff? There's no A's down here, so no. Yes, here's a B1, so if I get rid of the 1, since it's smaller, I'm going to subtract it from 4. That'll be B3 up here. And down here's a C, no C's up here, so we're done. So that's how you would do a fairly complicated problem using the rules. Okay, that's it for this part. Next part, we're going to actually introduce the function and what the graph looks like mostly, and how to use that graph using transforms from section 3. And then there'll probably be a third part to this section. We'll actually work some problems, maybe even a word problem.